Hi, myself Prabharan J, working as a assistant professor in ECE department at SNS College of Technology. In this lecture video, I am going to discuss about Verilog HDL in VLSI design. Before that, we should know about what is HDL. HDL is a hardware description language which is specialized programming language used to describe the structure and behavior of digital circuits. It is primarily employed in the field of digital electronics for designing and describing the functionality of electronic circuits. Hardware description language are used for the design, simulation and verification of digital circuits. They allow engineers to specify the hardware architecture and functionality of digital systems, which including details such as logic gate, flip-flop and interconnection. Hardware description language are essential tool in the design and synthesis of digital circuits as they provide higher level abstraction that facilitate that design process. There are two types of hardware description language. One is Verilog HDL and another one is VHDL. Here we are going to discuss about Verilog HDL. Let me see Verilog HDL. This was one of the earliest hardware description language and is widely used for digital design. It has evolved over the years and is used for both simulation and synthesis of digital systems. Hardware description language are essential for the design and implementation of complex digital systems such as microprocessor, memory units, and other integrated circuits. Engineers use HDL to model and simulate the behavior of these systems before they are physically implemented in hardware. The HDL code can be synthesized into a netlist, which is a low-level representation of a circuit that can be used to program field programmable gate array or application-specific integrated circuits. There are 4 levels of abstraction in Verilog: switch level, gate level, data flow level, and another one is behavior level. Let me discuss one by one. Let me see the first level of abstraction, that is switch level abstraction. In Verilog HDL, switch level modeling refers to a level of abstraction where the behavior of digital circuit is described using switches and transistors. This level of abstraction is closer to the actual hardware implementation and is considered lower level compared to the more abstract behavioral and register transfer level description. Switch level modeling is used to describe the functionality of digital circuits at a level that involves individual switches and transistors. It is a more detailed, realistic representation of how the logic gates and other components are interconnected and function within a circuit. Switch level modeling can be more complex and detailed than higher level abstraction. It may involve specifying the transistor level details of digital system. This level of details is often necessary in certain design scenarios where precise control over the implementation is required, especially in custom or specialized digital circuit design. It is important to note that switch level modeling is not always most practical common approach in digital design. In many cases, engineers use higher level abstraction like register transfer level or behavioral description to model and simulate the behavior of digital circuits. Switch level modeling is typically reserved for situations where fine-grained control over the hardware details is necessary. Let me see some examples of switch level modeling. Here a simple example to illustrate switch level modeling in Verilog. Module, okay. In this example, switch level module contain two transistors, which is NMOS and PMOS, and models the behavior of simple logic gate. The NMOS and PMOS modules are switch level representation of NMOS and PMOS transistors respectively. Okay. Next we will see gate level modeling. Gate level modeling is an abstraction level in hardware description language like Verilog. At the gate level, the design is described in terms of logic gates and how they are connected to form the desired functionality. This level of abstraction is more detailed than RTL, register transfer level, or behavioral description, and is closer to the physical implementation of digital circuits. In gate level modeling, the behavior of the circuit is described using basic logic gates such as AND gate, OR gate, NOT, NAND, NOR, XOR, and so on. Also, the interconnection between these gates are explicitly specified, indicating how the outputs of the gate are interconnected to the input of others by using wiring connections. Let me see some examples of gate level modeling. Yeah, this is the syntax of gate level modeling. First is primitive name, which means which type of gate we are using. Next, instance name, which is instance name, it is a optional one. Okay. Next, input and output. Here's example of gate level modeling. In this example, an AND gate implemented at the gate level modeling. The AND operator represents the logical AND operation, and the assign statement specify the gate level behavior. Gate level modeling provide a more detailed view of the hardware compared to higher abstraction level. It allows for precise control over the circuit structure and is often used in scenarios where the designer need to have a direct influence on a logic gates and their connections. Next, we will see the data flow modeling. It is a level of abstraction that describes the flow of data in digital circuits. In this style of modeling, you express how the output of your digital circuit depend on the input using continuous assignment. Continuous assignments describe the relation between signals in terms of Boolean equations, making it easy to capture the functional behavior of combinational logic. Let me see the examples of assign keyword we are using. Here a simple example of data flow modeling. In this example, adder is a module that represent a simple 4-bit adder. A and B are 4-bit input buses, sum is a 5-bit output buses. The assign statement is used for continuous assignment. In this case, it expresses that the value of sum is the sum of A and B. This is a simple example of data flow modeling where the behavior is directly described by the relationship between input and output. Data flow modeling is particularly useful for describing combinational logic where the output is determined by the current values of the input. It is an abstraction level higher than gate level modeling and provides a more concise representation of digital circuits behavior. Next, we will see the behavioral modeling. Behavioral level modeling is a higher level abstraction than gate level or data flow modeling. It focuses on describing the functionality and behavior of a digital circuit using constructs that are closer to the designer understanding of the system's operation rather than the actual hardware details. Here we are using some blocks. Always blocks. Behavior modeling often involves the use of always block to describe the behavior that occurs under certain condition or event. Next, initial block. Initial block are used to model behavior that occurs only at the beginning of the simulation. Also, Verilog supports both blocking and non-blocking assignment, and the choice between them affect the simulation behavior. Blocking assignment are used when the order execution matters. Non-blocking assignment are often used for parallel assignment. Also, Verilog provides if, else if and else statement for modeling conditional behavior. Let me see some example of Verilog behavior level modeling. Okay, here example of behavioral Verilog code for a hardware using if-else statement. In this example, A and B are the input bit, sum is the output bit, carry is the output, and the always at block is used to describe the behavior. The if-else statement capture the logic relationship between input and output. Each condition corresponds to a specific combination of input values, and the output sum and carry are as sum and carry is the output. Okay, let me see the modules and instantiation. Okay, in Verilog, a module is a fundamental organizational unit used for hierarchical design and modularization. It encapsulates a set of functionality or a specific part of a digital design. Modules are the building block of a Verilog design, and they help in organizing and managing complex digital systems. A Verilog module is a logical unit that defines the behavior and structure of a digital circuits. It can be viewed as a block of code that represents a specific functionality or component within a larger design. A module typically contains input and output port and internal signals, and the behavior or logic that defines how the module operates. Let me see some example. In this example, my module is a simple module with two input which is A and B, and the output Y. The behavior of module is defined using the assign statement, which perform bitwise AND operation on input A and B and assign the result to output Y. Next, instantiation. Instantiation is the process of creating an instance of module within another module or at the top level of the design. It involves connecting the ports of instantiated module to signals or ports in the surrounding module. Let me see some examples. Okay, here an example of how you might instantiate and use the my module in another module. In this example, top module instantiate my module using my module my hyphen instance. The signal x and y from top module are connected to the input A and B of my module, and the output Z of top module is connected to the output Y of my module. Module instantiation allows designer to build complex system by combining simpler module. It promotes modular design practices, making the code more readable, maintainable, and scalable. Each module can be designed and tested independently, and overall design can be easily understood by looking at the hierarchy of instantiated modules. Okay. Okay. If you have any doubt, you can ask me through comment. Thank you.